Okay, so last time I started to explain multiplexers. So I told you, as you see here in this figure, in multiplexer, we have some inputs, we call them selectors. So these are selectors. And also, if we have n selectors, we should have 2 to the power of n lines. Okay? The idea is that multiplexers are simply like a switch. So we have only one output here as we see, and actually it is like a switch. So if the selector is number zero, so line number 0 is actually connected to the output. So the output here is equal to the input number 0. It's pretty easy. That means if input number 0 is 0, I'm gonna get 0 here. If this is 1, I'm gonna get 1 here. Okay? And by changing this number, for example, if I make it number 7, so line number 7 is gonna be connected to the output. So the output here is connected only to one input. Which input? We have inputs here from 0 until 2 to the power of n minus 1. Which one? This is what the selector is gonna do. Is that okay? This is multiplexer. That's what I explained last time. Also, interestingly, I told you this multiplexer is very close to decoder. It's very close to the decoder. I'm going to tell you what is the difference. So if you see here, for example, if you have 4 to 1 multiplexer, 4 to 1 means always it's 1. So we have only one output here. 4 means we have 4 inputs, and because you have 4 inputs, so this is, I need 2 selectors because the relation is actually n here, 2 to the power of n here. Okay, so as you see here, I have here 2 selectors. I have here input 0, 1, 2, and 3. Okay, so the way we are going to design it is for each input we need one end. This is exactly similar to the decoder, if you remember. The only difference is, so as you see here, we have here it's 0 prime, it's 1 prime. Okay, and it was I0. This is the main point. So now focus now. So if the input is actually, this is actually the main term for input 0, 0. This is the main term for 0, 0. So actually when the input here is 0, 0, so actually this one becomes 1, this one becomes 1. 1 and I0, so the output here is going to be I0. What about the other ones? For sure, the other ones, there is a 0 in one input, at least one input is 0. That means this one is 0, this one is 0. So that means this is how it works. If the input is 0, 0, only one end is going to be activated, okay? Because only one end is going to have 0, 0 here. This end here, for example, in case of 0, 0, so only one end is going to have 1, 1 here, and I0. All the other ones are going to give me 0. Let's have another example just to understand it well. So, for example, if you look at number 3, okay, so number 2, okay, so here, for example, this is number 2. And number 2 here we have 0, 1. This is number 2. The main term for number 2 is actually S0 prime and S1, as you see here. So I end it with I2. Okay. So when the input here is number 2, so here we have here 1 and the I2 here, and the output of this end here, the output is going to be I2. All other ends are giving 0. Okay. Any questions? Number 1, you need to understand, guys, here. Number 1, what is multiplexer? Okay, it's a circuit. What this circuit is doing? Very simple. You have one output. You need to select out of 2 to the power of n inputs, and that's why I need n bits here for select which out which input has to be connected to the output here. How can we design it, or how we can make a multiplexer? The way we make it is, so as you see here, it's very similar to the decoder. Very similar to the decoder. The only difference, in case of decoder, we just cancel this one. Okay, that's why it's very, very similar to decoder. Okay? Same thing here for 8 to 1. 8 to 1, as you see, exactly same thing. In case of I0 here, so I have to put here the midterm for I0. So that when the input is 0, 0, 0, these three are going to get me 1, 1, 1. Okay? And if you have 1, 1, you have here, and in case of A, you have 1, 1, 1, and then you have I0, so I'm going to get here I0, whatever the value of I0. Same thing for the other ones. In case of I6, so I have to put the midterm for I6. Okay? In case of I3, I have to put here, it has to be ended with the midterm of I3. Any questions? Okay. So here, this one is a chip. It's 151 chip. Okay. This chip is actually 8 to 1. 8 to 1. That means because I have 8 inputs, how many selectors I have? I have 3 selectors. So if you see here, we have 3 selectors here, ABC, and we have 8 inputs here, and we have only 1 output. Okay. But actually here, I give you 2 outputs here, okay? They are the same, but one of them is inverted. So usually we like to do that in logic circuits. Usually I like to give you the output in two formats, like F and F prime, okay? So that whatever you want. So if you want to take F, okay, you can, it goes in your design. If your design needs to take F, if you want to take F prime, you can take F prime, okay? That's why you see here as the output, this is the output. The output is Y, and also I give you Y prime. Okay, so in case of Y, here, if you select, for example, input number here, I call it G. Okay, for example, if I get here input G number 6, I will get it here. Here, I'm gonna get G6 prime. You understand what I'm saying? So just I give you 2 outputs, whatever you want. I give you the same input, and also I give you the complement of the input. Okay, in this chip. Also, similar to what we did before, we have here an enable. Can you see the enable here? We have an enable. And this enable is, I told you last time, when you see a bubble like this one, what it means? What it means? Active low. Active low means if I want to enable, I have to put 0. It's going to be active by 0. You got what I'm saying? If there is no bubble here, just this way here, that means it's active high. To enable it, I have to put 1. Okay? How can you add enable? Very easy. So for example, if I look to the, if you look at this one here, how can we add enable? Just very easy. All what you have to do here, I'm gonna add 1 input here, 1 extra input. I'm gonna connect this input to all of them. That's it. That's it. So that if this input is 0, so all of them are off. Okay, all of them are off, or all of them are gonna give 0. Output is 0, regardless what input you have, regardless what is the number on the selector. Very easy, right? This is if you want to make it, if you put 1, okay, if you put it 1, now it's gonna work normally. If you want to make it active low instead of active high, very easy. All what you have to do is just add inverter here. You add inverter so that 0 is gonna make enable, 1 is gonna make disable. Any questions? Okay. Yeah, so here, this is a truth table for this decoder. As I also explained before, if it is disabled, so 1 here means disabled. So if the enable is 1, it is disabled, so the output is going to be 0 for Y all the time, regardless what is the value of the selector. Okay, because it is disabled, it's going to give you 0 all the time. It's not working. But here, if the enable is 1, so now it is working. So now it's going to work normally. So if the input is 0, output is D0, and this one always going to give you the complement. If the input here is number 4, I'm going to get here output here equal to input number 4, and you have complement on the other one. Any questions? So in this lab, in this week lab, you are going to work on a chip. I don't remember if it's 151 or 153. I don't remember, but you are going to work on a similar chip like this one. If you remember also last time, I think one student asked me last time, is that always here I have to select these inputs are always 1 bit, okay? Like what I explained here. No, you have to keep in mind. This is something you can design. This is a design. You know what I'm saying? So you can make it with enable. You can make it without enable. You can make the enable active high. You can make it active low. So this is a design. You can design the way you need it. So everything I designed so far, yes, the input was only 1 bit. So that doesn't mean it's always this way. Sometimes, not sometimes, it's especially in computer systems or computer architecture. Sometimes you have numbers. For example, you have here any bit, number A, I have here number B, number C, and number D. So these numbers are stored in what we call registers. I'm going to explain by the end of this course what is a registers. So here we store some numbers here, and now I wanna take this one to send it to the ALU to do addition, for example. So in this case, I need a selector. I need to put here a multiplexer. So this multiplexer has any bits from A, any bits from B, any bits from here, any bits from here. And then based on the selector and the output also is any bits. You got what I'm saying? So that by the selector, I can select which number, should I take A or B or C or D to send it to the ALU to do addition. For sure, it depends on the assembly instruction you have. So the assembly instruction you have, I want to add register A, so the hardware is going to put a number here in the selector so that the number here in A is going to go to the ALU. You got what I'm saying? So yes, sometimes we need the case when the input here is actually more than one. Okay, so here I'm explaining how can we do it. So here, if you see here, I show you, I have multiplexer here. In this multiplexer, I have here, the input here is 4 bits, for example, number A, 4 bits number B, and the output is 4 bits. And I have only 1 bit for selector, okay? So that when I select, for example, here 0, for example, A is gonna go out. Or if I put here 1, B is gonna go out. So select, so I have to select between A and B, 4 bits or 4 bits, okay? So let's see how I can do it. It's very similar to what I explained, because keep in mind, the 4 bits here is actually, it's 4 bits. So I can do it using 4 multiplexer, 2 to 1 multiplexer. Look how I made it. So here, I am going to use 2 to 1 multiplexer. Everyone here is 1 bit. 1 bit. But the way I'm going to do it, as you see here, in this input, I'm going to input B, 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 B. Okay? And all the selectors are connected together. So that here, when I select here, for example, here I put number 1, assuming this number 1 and this number 0. If I put here number 1, so this one is going to give me number 1, this one give me number 1, number 1, number 1 here. So you can see here, yes, it's multiplexer for 4-bit input, 4-bit output, but I created it using 1 bit and 1 bit. You got what I'm saying? So yes, I can do this one. Also, if I input here 0, in case if I input here 0, so actually A is gonna be out here, A, okay? So for sure, this is for 4 bits. You can add more if you want. So if you see here how we can do it, it's exactly similar to what we did before, exactly same thing. So here, if you see here, we have here a selector. So this selector, as you see here, for example, here, if this selector here is, if I put 0 here in the selector, so this one becomes 1 and this one becomes 0. So when this one is 1, so here actually 1, 1, 1, 1. So I'm gonna enable this and this here, okay? If you put here 0, so all of these ones are the same, okay? So when I put here, not enable, I'm sorry, I'm gonna select this and this here. Okay, so here we have A0, so A0 will go out here, A1, A2, A3. So it's exactly similar to what I explained before. Well, I'm going to use AND, I'm going to input the selector. So if you see here, when the selector equal to 0, this one becomes 1. When this one and this one is 0, when this input here is 1, actually all of them are 1 here, and the output is going to be A. So this thing I'm going to select A. If I put here number 1, so here this one is 0, okay? So all of them here are selector 0, selector 0, selector 0. That means all of these are off. So I'm gonna hit 0, 0, 0, okay? And here 1, 1, 1, 1. So I'm gonna hit here B0, B1, B2, B3, okay? And you see here I need 1 OR between A0 and and B 0, as you see. By the way, I just do it this way, but if you, the way you can see it is, this end and this OR together are actually one multiplexer. It is 2 to 1 multiplexer. Okay? So this end, okay, and this OR is actually one multiplexer. Either I can select this one or this one. Okay, guys, any questions? Okay. I'm gonna come to the last part, which is what we need. Also, I explained the same quickly, but today I want to elaborate it a bit. Similar to the decoder, last time I explained how can I use decoder to implement any function. So if you have a function, you can use decoder to implement the function. That's what I explained last time. Okay. Also, last time I explained same thing. How can I use multiplexer also to implement any function? And that's what we are going to do in the coming lab. In the coming lab, you are gonna use 2 chips. One chip for multiplexer, the other one for decoder, and you are going to implement functions. Okay. So here I want to show you how we can do that. It's a very naive way, or the very simple way I can do it is, if you have 3 inputs here. If you have 3 inputs, okay. So I'm gonna use a multiplexer with 3 inputs, as you see here, multiplexer with 3 inputs. Okay. So because we have 3 inputs here, so here I have 8 cases. Okay. So all what I will do is just copy. I will copy the function you have here. Okay. So that when the input is 0, 0, 0, I'm gonna put here 0, so that I'm gonna get 0. So this one is coming from the first input from here. Okay. If I put here number 1, so whatever here at number 1 is connected, right? So here it's not, number 1 is connected. So here, whatever we want should be the same like this one. You understand what I'm saying? Same thing, for example, if I put number 7 here, I know the multiplexer is going to connect to number 7. So what I'm going to put here is the value, of the function 1. You can understand? Any questions? This is very simple way. Why we can improve it. We can improve it. This is a very basic idea. Why it's basic idea? Because here, if I have 3 inputs, I need a multiplexer with 3 inputs. Okay. I will show right now another idea. I can do the same thing, but instead of 3 inputs, I can do it only using 2 inputs. Okay. So I can implement. So here I implement this function with a big multiplexer. Okay. I will show right now how I can implement this function using a small multiplexer, smaller one. A smaller one here means here I do it using 2 to the power of n. So for inputs here, okay, where n is the number of inputs we have in the function here. So let's see. Okay, in this case, how can you do that? How can you do it? Okay, that's what I'm explaining here. So what I'm explaining here is exactly the same thing as I did before, but I want to implement this function using the smaller multiplexer. The smaller multiplexer means here I have 3 inputs. So now I'm going to select one with only 2 selectors. So always the relation is if you have n, if your function has n inputs, the number of selector n minus 1. Okay? So if your function has 4 inputs, so in this case I need 3. But in this basic idea, here this one is n, this one is n. Okay? So that's what I want to show. For sure, nothing is for free. We have to do something. So let's see how I made it. So as you see here, guys, I'm gonna connect here X and Y to the selector here. With the selector. Is that okay? This is number 1. And then so here this part we're gonna use it for selector X and Y. And then I know if you look here guys in this part, this is 0, 0, 0, 0. That means for these two values, only one output is going to be connected to F. Is that okay? For these 2 values. Now, what I'm going to put here, after that, I will see what is the relation between Z and F. What is the relation? I will find the relation in either F equal to 0 all the time, F equal to 1 all the time, or F equal to Z, or F equal to Z prime. I will see whatever the relation, and then I will input it here. Okay, so let's look in this case. In this case here, when Z equal to 0, F is 0. Z equal to 1, F of 1. So what is the relation? F equal to Z. So I'm gonna put here Z. So that when this is the input, I will get 0, similar to Z. If this is the input, okay, I will connect the same line. So from these two inputs, I'm gonna connect the same line here to the output. I will get one similar to F. Let's see another example to understand what I'm saying, okay? Let's look at this here, number 1. And number 1 here, so number 1 is connected to F. Is that okay? Now let's look at the relation here. You can see the relation is when Z equal to 0, F should be 1. When Z equal to 1, F equal to 0. The relation should be Z prime. So I'm gonna put here Z prime. So that when this is the input, or this is the input, I will get correct result, okay, which is gonna be Z prime. Okay. Let's look at the next case here. Number 2. In number 2, I know only one input here is connected to the output, as you see here. Look at the relation. The relation is F is always 0. So here I'm gonna put 0. It's always 0. You got it? You got it? So you can see the difference here, guys, between this slide and this slide. In this slide, if the number of inputs of the function is in, I need multiplexer with n here. But this one, I'm gonna make it using shorter or smaller multiplexer using n minus 1. Okay. Another difference here, I put the value, the function itself, or the value of f here. I just put it here. But here, because for every 2 inputs, this one input is connected to the output for 2 inputs. So I need to find what is the relation between F and Z. Okay, and it is either F equal to Z, and I connect to Z. F equal to Z prime, I connect to Z prime. F equal to 0, I connect to 0. If you look at the last one here, so here, F equal to 1. So that's why I'm gonna put 1 here. Okay, so it means always when these two X and Y 1, 1, I have to have 1 here, regardless what is the value of Z. Any questions? You see it? Thursday, there will be a quiz. The quiz has 2 parts. I will give you a function. I will ask you to implement this function using decoder and using a multiplexer like this. Is that okay? I sent you an email. I'll give you 2 slides. You need to study for the quiz. Okay? Same thing. That's what you will do in the lab this week anyway. Okay. So I give you another example. Okay. So here we have 4 inputs. So here, because it's 4 inputs, I need 3 selectors here. Always the relation using this way is n minus 1. Okay. So as you see here, when you have here again, I'm gonna connect these 3 ABC to selector here. ABC to the selector. That means in this case, in these cases, the output here is connected to 0. In these 2 cases, again, you have to see what is the relation between F and Z, F and G, or if the relation is F is equal to G. So I'm gonna just connect G here. Okay. If you same thing here, number 1, we'll connect to number 1 here. Okay. Same thing, F equal to G. Okay, so I'm gonna connect G here. Okay. Let's look at the next one. So here, look at the relation. F equal G prime. So here I'm gonna connect G prime. Okay. If you look at the next one here, so here in number 3, when you connect to number 3, okay, in number 3 you can see it's always 0. That's why I'm gonna put here 0. Here it's always 0 in case of number 4. Let's see number 5. Number 5 here, 0, 0, 0, 0. So equal. So I have to put G here. Okay. Number 6, it is always 1. That's why I'm gonna put here 1 all the time. Number 7, always 1. Okay. Okay, guys. In exams and anything, so you don't need to do this way. You can simply tell me this is G, this is D prime. You don't need to show me the exact connection this way. You put just 0, 0. Okay. Here we have G, just 1, 1. Okay, this will be easier for you when you solve, easy for me when I grade. Okay. Any questions? So now you see the difference between what I did here and what I did in the beginning. In the beginning, this one was N, and here I used N. Here, I used a smaller multiplexer. If I have here N, so here I need N minus 1, smaller multiplexer. Is that okay? in the coming lab, let me ask you a question. Can I implement it using a more smaller than this one? Can I do that? The answer is yes, but you are gonna complicate it here. You need to make it, and that's what you are gonna do in the lab. You are gonna complicate it more here. How can you do that? Okay, look here, guys. For example, this one here, I'm gonna implement it using only 4 to 1. In case of 4, so I have only here 2 selectors. I have S0, S1. Is that okay? 2 selectors. Okay, so now so this is the selector. This is the part for selectors. Okay, so now, so I'm here, for example, here. So now, when this is the selector number 0, okay, 1, 2, 3. Is that okay? We need only 4 inputs here because this is the selector 0, 1, 2, and 3. Okay, so if you want to do it is, yeah, so this is the multiplexer here. I'm going to input here the selector here is actually A and B. Okay, and now I have line 0, okay, line 1, line 2, and line 3, and we have only 1 output here. Okay, but be careful here. So what is the problem here? The problem is, as you see here, in 4 different cases, you are going to connect number 0 to the output. The 0 here is going to be connected to the output for 4 different cases. Is that okay? So what should I put here? What should I put here? Very simple. What you have to do is, you have to create a function here, and you have to put whatever the function you have here. You have to put the function here. Okay? Let me be clear. Okay? For example, in this specific case, you can see here, this one is 1 here in this case, similar to what we did before. If you want to do simplification, you can do simplification, but it's very clear here if it actually is C prime D, or I'm going to take this one and this one, CD. So all what I can do here, I can make or here, I can make or here, and then I can make and here, and another and here. I put here C prime D, and actually I put CD here. Did you see what I did? Again, the problem is in these 4 cases, the output is connected to 1 input. Is that okay? I have to make sure the value I will have here is going to be the same like if a different values of C and D. Okay? So how can you do that? You need to find f as a function in C and D. How can you do that? That's what we have been doing this course for a very long time. I have to look for the ones. Okay, if you want to use math, you can use math, but this is just a very small, you don't need math. But here, this one here, so it's going to be CD prime or CD. So you need to implement this. Same thing you have to do for number 1. Same thing you have to do for number 2 and number 3. So what happened now, I will take your question shortly. So what happened now, yes, I reduced the multiplexer. It became very small multiplexer, but I'm going to make it complex here. Okay, it becomes more complex here. Yes.
Why not still just be D by itself?
What is that?
Would it still be D anyways? Because you could with the C prime D and then or CD, and then you can get out the manipulation to get rid of the C prime and the C.
Yes, that's a very good question. Yes, I didn't do simplification, but yes, that's why it became complex here. I didn't do simplification. That's a very good question. But if you take G as common, to become C prime or C, which is equal to G. Yes. Because I'm saying, because I didn't do simplification. Yes, if you do simplification, you don't need to complicate it this way. You can, yeah, in this case, it's going to be only G. Okay. But thanks for this point. It's a very good point. Okay. Let's do one more example before. Yeah, I'm gonna do one more case. For example, if you look here, same thing here, guys. If you look at this case here, okay, this is very easy case. So you can see here the relation is 1. It only have only 1 here. So it's actually going to be C and D. Is that okay? So you have to come to this input number 2. You have to put here and you have to put here and C and D. Okay. If you look at the last one here, this one. If you look at the last one here, look here, guys. It's actually 1, 1, 1, 1, 1. When the function is 1, 1, 1, 1, You don't need to get min terms, f equal to 1. So this is the function, it's always 1. So the next one should be only 1. Okay? Is that clear, guys? Same thing here, not 1. I almost sorted all of them. So when I post the video, you can go back and see what I did again. Okay? So if you look at, for example, this case here, we have only 1 here. So actually here f should equal to c prime g prime. So I have to come here in this input, which is input number 1. I have to do c prime and g prime. Yes. Okay. Any questions? That's what you have to do in the coming. Okay. I think that's enough for today. To start this.